Hey guys, what's up? Eddie Aho here with KissAnalog.com. Hey, have you guys ever thought about building a Class AB amplifier? Have you ever wanted to buy a set of boards and assemble one? Well, I have a set of boards right here. I'm going to give a set to one of you lucky guys that wants to help me out with this, okay? So let's talk about this. But first I want to introduce what these boards are, okay? Now the Honey Badger board, I believe that was designed by Pete Vogel, okay? And it's been celebrated. It's been, I mean, everybody's given positive reviews, praised it, and I haven't found anything negative. I did some searching, and man, it just seems like it's a great Class AB amplifier. Some people say you can't buy one better than this one. So I don't know about those things, but I do know that a guy named Stuart, he's a subscriber to the channel, so he reached out and told me that he's been working on this project and that it's ready for prime time. So it turns out he's a mechanical engineer, and when I looked at the documents that he did, there's a document that they put together. He put together a team. Well, a team assembled. I don't know who put together, but Stuart is really interested in designing an amplifier, and the Honey Badger looked awesome, but as he read books and as a mechanical engineer, he wanted to learn some electronics, wanted to learn about amplifiers. I found over the years that physicists, school teachers, science school teachers, and math teachers, different people in science get involved with building amplifiers because it's just something interesting. It's something they can put their science in something physical, and they can get something back from it. After they got the amplifier built, they can listen to it. So it's just a neat way to apply your sciences, and it's fun, right? Build your own amplifier. So Stuart looked out there and he started learning about it, and he was asking, I think he asked Pete Vogel some questions about his amplifier, and anyway, discussion came up that he and this team wanted to improve on it, like basically redesign it, revamp it. And so they did that, and I think Pete Vogel helped a little bit, and this team got together. There's a couple people that are notable that have been on the audio file boards. I've seen their names show up here and there. Anyway, they got this looks like a really great team, because the product they ended up with is pretty fantastic. And this thing, I'm going to show you the test results. I'm going to show you pictures of this board, the assembly process. There's another guy on YouTube, Daniel. He's part of the team. He's built one of these and videotaped it, and those videos are on YouTube. So, but I do have this set of boards, and I didn't open this until today when I was going to do this video, because I wanted to make sure they were, it says fragile. Wanted to make sure they're taken care of. But guys, these boards are pristine. I mean, they are like the top quality. So, and it looks like the initials of some of the members of the team are on here, or maybe all the members of the team. Yeah, so that's really cool. That's really neat. So, anyway, what we're gonna do is, by the way, it just reminds me, I was talking to some guys, and I've got a design I did that's on the space station. It's on the German side of the space station. They bought this design I did. It's a little power supply, basically. But anyway, I put my daughter's initials in it. So I kept one of those boards so I could give it to her. So yeah, you can do cool things like that. Get your initials on the board. People build them. It's just kind of cool. I like that. So, all right, guys. So when they did this design, they didn't just take out of a book or off some other design that said this part of the design is supposed to be awesome and include that into their design. They tested everything, and they went to the, to the nth degree to make sure that they had as perfect as an amplifier they could. So they didn't hold back, and the test results show that they're just crazy good. It's just nuts. Especially these last videos I've been doing. You can see the noise, that I've been dealing with. I mean, their instrumentation, I have the Quant Asylum, fairly inexpensive, but really, you know, capable analyzer. The analyzer they used is another level. It's an expensive thing that's capable of going down even further in decibels, which is like, who really needs to go down further? I mean, geez, there's a point of like, wow, you know, when you have a THD plus noise of 0.000, like how many zeros are you going to go before you just say, hey, this thing has zero distortion? Man, anyway, I think that these people could say that. This thing's incredible. So let's come over here, look at the boards. Let me show you the documentation, all that kind of stuff. But the original Honey Badger has turned into the Wolverine. So this is the Wolverine. And this thing is going to be a big splash. You're going to see it in audio forums for some time. So they kind of call it the son of the Badger. Son of Badger, I guess. Wolverine, son of Badger, I think is what they call it. So, yeah. So it kind of grew from that design because it has such great following. Anybody that was interested in that will likely want to build a Wolverine. So, okay, who wants to build this? Well, let me show you this stuff. There's a lot of documentation. These guys, you know, like say, engineers, you can tell the documentation they put together is like 71 pages, Rev 30 or Rev 33, something like that. I mean, they documented everything. They did a very professional job. I mean, no engineering design team's gonna say, oh, you left off this or that. I mean, there's always something you could have done, but I mean, I think any other design team would look at them and say, wow, you guys did a great job. So let's come over here, take a look at it. Hey, one thing I want to do, I have my notebook here. I just want to read what they put on the front of their document, okay? It said, a precision Class AB amplifier designed by fanatics for fanatics. So I read that and I thought that's kind of funny because fanatics. They didn't say audiophiles. I thought that was interesting. Man, since I got into audio years ago, the word audiophile, man, the audiophiles, you know, like believing and spending thousands of dollars for a power cord, things like that, the craziness that road has led to has changed, God, I mean, back in the day, if you called us audio fanatics, we would have, come on, man, we're not fanatics, we're something else, we're audiophiles. And if you break down that name, what audiophile means, it's like lover of audio, right? Files or, you know, audio lover, you know. It's like, how did that name, how did the audio community, you know, the manufacturing people out there, they have just let this perpetuate because all these beliefs into these craziness, this ludicrous stuff has just gone rampant where people, serious people that are really serious in audio have had to change their name from audiophiles to fanatics. Wow, that tells you, you know, the craziness that there is with audiophiles. I mean, it's, wow. You know, someone who says, well, don't listen to science, you have to just listen and then you'll believe. It's like the belief camp. It's like, wow. It takes engineers to design these amplifiers that they listen to, right? But yet they won't listen to the engineers saying that, oh, no, that, yeah, don't be taken by an expensive power cord. That's garbage. Yeah. Wow. It just blows me away that now we're calling ourselves fanatics. Guys, I think we ought to take back the word audiophile and call them fanatics. Let's do that. Let's call, you know, let's call a spade for what it is, you know. I mean, if you're an apple, you're an apple. So if you're a fanatic, you're a fanatic. But audiophiles, people that love audio, we should take that term back. We shouldn't let that get muddied and destroyed by the fanatics. So I think it's funny that they named it that. That's why I wanted to read that off. I think we had to take it back. This video's turned into something of a rant. Anyway, sorry about that. I just want to introduce this new Wolverine amplifier, and let's see who wants to build one. First of all, let's come over here and look at all the stuff. We'll talk about that after this, okay? All right. All right, guys, so let's start off looking at the specifications to see what this thing will do. So rated power, now remember, this isn't like, you know, what Texas Instruments does, 1%, 10% distortion. This is nice, clean power, okay? And we're going to show you those curves after we look at this to show you how clean it is. It's crazy. 8 ohms, 240 watts, 4 ohms, 430. Now, this is with 71 volt rails, okay? 64 volt and so on. They're breaking down all the specs really well. Frequency response, 20 hertz to 20 kilohertz, 0.1 dB. Zero, you know, you'll get no plus, but you might dip 0.1 dB. So that's crazy good. But you actually have a wide bandwidth down to 5 hertz to 180. And you have a little bit more dB, you know, range on that, but that is still crazy good. So that gives you a wideband amplifier. People have found that faster amplifiers can help with distortion within the audio band. So this is a very fast amplifier, 180K. Total harmonic distortion. All right, guys, look at that. That's crazy. Yeah, that is just so many zeros. Man. Signal noise ratio. I mean, look at that. Crazy. 117 dB. It's not easy to measure these numbers, guys. Slew rate, 75 volts in a microsecond. So you can change 75 volts in a microsecond. So that's, again, crazy good. Number of output devices per channel, 3 or 4, depending on what you want to do. And dampening factor. Let's kind of look at their story here, the introduction. This Pete Vogel, he is the one that was behind the Honey Badger, and he also helped out a little bit on this amplifier, but is really this team. I'm going to give you the names down below, but yeah, he had his input in this, and they reached out. You know, they really tried to make sure they created the best amp they could. But the Honey Badger, from what I've seen, has had great reviews. If you guys know of that, please leave the comments below. So now we got the Wolverine, the son of the Badger. Alright, so let's go look at some of the curves. Alright guys, so what I want to do is I want to show you this document. This document has, we're going to look at the specifications, but I want to show you just this really nice document that they've put together. And look at this, revision. There has been some work done on this to bring it to where it is today. So it's pretty darn polished. So you're not getting something that hasn't been tested and retested. So back to the front of this guide, I just want to go through the table of contents just to show you how well it's put together. We're talking about, I'm going to just jump around and show you some of this stuff, but they have covered, I think if you have built anything, I think if you've built any amplifier in your time or any electronic gadgets, I think, you know, with the descriptions and how they explain how to install things and how to build things, I think you could do it. But what I want to show you also is, look at this. Look at all the testing that's been done. And you just take a look at that. These tests up here, they're just different types of ways to try to measure distortion to see if your amp behaves properly. And then also the square wave testing, which I've never really been a huge fan of that, but yeah, I think the way they do it, they show how clean it. And what this does do is it shows how fast an amplifier is by showing you the edges, and the slew rate is the edges, right? So yeah, and then revisions. So All right, so let's just jump around a little bit and take a look at this document. But just to show you the quality of information here, they talk about component selection, and some of this can be left up to you. If you know that you want a certain type of capacitor, a certain type of component, then, you know, they're talking about how you choose components, and they're pointing out some of the books that have been, you know, read and reread by these guys to understand amplifier design. Clean and inspect, input impedance selection. So yeah, you know, I always say when you start a project, you want to make sure everything's clean, and you want to inspect, you know, do a visual inspection just like they're talking about here. Starting the build, inspect, and trial fit hardware. So trial fitting hardware, just making sure, it's called a fit check. Just fit check things. You know, you bought the connector, did you buy the right one? Just simply test it on the board. Now, this is the header right here, across here. These standoffs, they're talking about the spacing to make sure you got the proper spacing so that these things fit properly and that the alignment's correct and all that kind of stuff. So, you know, there's just all kinds of details in here that will help you build this amplifier correctly. Some instructions here, just an example, you know, talking about the jumpers over here and these little via solder joints. They're just pointing out things that you'll need to know as you build your amplifier. Okay, heatsink assembly notes, right? A lot of people make mistakes on the heat sinks and assembling, and they're going to go into details and show you how this is done. So more about the heat sinks, just because this is such an important topic, and I just want to show you how well they do, covering what it looks like and the photographs. They've done some, you know, terrific jobs on the images. Okay, still on heat sinks, just because I think a lot of you guys would appreciate this, showing you how they put them together. This little guy here can be used, I'll show you in a moment, but it can be used to help ground this heatsink to your grounding on your board if you want, to help support it as well. Now that's a nice looking board, right? You can see the plating on the board, how, I mean, this board is just high quality. Okay, so here's some of the pins that they're showing how the heat sinks can mount to the board. So what's interesting is they're showing the mechanical drawings. I like this. You can tell they had a mechanical engineer on their team, right? And a mock-up. You know, it's kind of how you just start to kind of put things together to kind of see what it looks like. It's kind of like that fit check. See how things are going to go together. Nice quality resistors. Nice quality components. You can see the quality of the board. Now, this is an interesting section. Create and install your output coil. So, really cool. If you haven't done one before, they're going to show you how to do it. There's your output coil right there. And look, just even basic stuff like installing input and output power rail attachments to hardware, this heavy duty stuff. So sometimes, you know, if you don't know, if you haven't done it before, it can be a little challenging. Installing transistors. This is something that audio guys like to see. Matching transistors. So discussion on how to do that. And coming down here, you can see how they're thermally pasted together, and then there's some heat shrink. So you end up with these guys over here on the right that I'm showing. You can look down here on the board, you can see how they're mounted, and so that's to thermally let them track. You know, so these transistors are the same temperature and they drift or don't drift the same way or together. All right, and so then the schematic. You can see there's quite a few transistors. There's these guys have not missed a beat. They're showing where to take your digital multimeter measurements. Okay, so this is all really cool stuff. This stage right here, the PD plus, PD, right here, ND minus, I'll show you where that picks up. You can see the fuses here for the voltage rails to power your voltage rails here. So, okay, and this is the next stage. Okay, this is your emitter follower stage. You have, in this case, look at all these transistors that are in parallel. And here's your output coil over here. And then there's that PD plus and ND minus connection. So yeah, you can see these little regulator stages down here. And you can tell throughout the design, it's symmetrical from plus to minus. I mean, you have this bias network that's in here, but as far as like the regulators, the output stages, the input stages, there's all this symmetry. Okay, here's some of these measurements I want to talk about. Look at these decibel levels. Minus 145, minus 155. I mean, that's just nuts. Look at this thing. You just don't see anything except for the signal. This is minus 130 dB right across here. That is just crazy. Now here's another one to test. Okay, this is over here 20 kilohertz. And look at the second harmonic, 123, 125, 127. I mean, you can see these little guys down here. This is at minus 120, this line. These guys are just peaking above 130. So, yeah, another one of the tests. I mean, just 120s, 130s. I mean, just outrageous. Like, just no noise. All right, so here's another test. This is, we have the two signals, the 60 hertz and the 7K hertz, right? So we come down here and look at this. There's just nothing going on down here. It is so quiet. This line right here is minus 110 dB right here. That's nuts. All right. So then there's also the DEN test. Like I said, they're trying to hit every test they could find. 250 hertz and 8 kilohertz. You can see them and look, oh, there's this little teeny thing, but that's minus 110 dB over here. And this is a multi-tone test. I like this test. All those peaks are hitting the same line, and there's nothing going on in between them. There's a couple little guys down here again. This is minus 100 right here, minus 110 right here. So, wow, just super clean. And this document also goes into showing waveforms, okay? All right, then we got the square wave stuff. Here's 50 kilohertz. There's 100 kilohertz. There's 10 kHz, 100 volts peak to peak. 20 kilohertz square wave, 100 volts peak to peak. Nothing wrong with those waveforms. And then here's 10 kilohertz square wave, and they're showing that edge. You know how I talk about that people never show the edges, the rise times? Well, they're doing it here. Yeah, look how clean that is. 10 kilohertz, 5.55 volts peak to peak. Now here's the slew rate testing, 10 kilohertz. They're taking a measurement of that rise time right there, 67 volts per microsecond. Okay, guys, there's a board mounted to a heat sink with all the output transistors. Really nice looking board. And here's the team. Yeah, I just wanted to show you the names of the team there. And Stuart right here, he is our contact. So if you want to reach out to the team, just reach out to Stuart. Daniel here has videos on YouTube showing how to put this thing together. So he's already done a series of videos showing how to assemble this. Okay, I just wanted to show you a few pictures, photographs of the schematic, just kind of showing the team. I mean, the work, it's just really nice looking boards. I mean, these boards are just pretty awesome. I mean, look at that. So you print off your pages, and it helps you build your project, because you can just flip to the pages and keep it right there on the bench. And here's part of the bench setup that you can use. You guys might have something similar. Now look at that board. Look how that's just a very nice made board. There's the main board with the daughter card sitting on top of it, and nothing soldered, of course. It's just kind of a fit check, just seeing how everything's going to go together. But the quality of the board is just amazing. There you go, standoffs with some washers on the board. Just another look at the board just to see the quality of that board. And also the spacing between parts and the placement of parts. It just looks like it's been put together and thought out really nicely. The silk screen looks amazing. And look, here's the selection of resistors. If you're trying to get values that match, that's one way to do it. Measure them and put them side by side. Then when you want to grab some, if you want matching resistors, you can find which ones are more closely matched. And this is just an example of them taking measurements, putting the Kelvin clips nice close to the body of the resistor. Now this is just a diagram of the power supply, just showing the ground part where you're going to have multiple pickups to bring your grounds to the same spot, basically as start ground. And there's your boards, partially populated. Looks like the resistors and diodes are going in. Yeah, there we go. We're getting ready to start putting transistors and capacitors in. Okay, now I think he's showing off his soldering. Nice job. Okay, these pictures are kind of showing how to assemble this grounding pin that you can put on your heatsink. There's a soldered together, and there's a star washer where you're going to mount it to the heatsink. And there's a mounted. And here it is on your board. The little pins on the opposite side that we can see. So it's right here in the middle. And there's the pin side. You can see the pin right down here going to the board. There's the heatsink with the Kapton tape on the heatsink. They show pictures of how to apply the Kapton. I mean, they don't miss anything. There's nice pictures showing the transistor positioning and the transistors that are heat shrunk together. And there's also some computer generated drawings to help the assembly, or the visual. But that might have been taken even before they had the actual boards. But now with the actual boards, they have actual photos of these things. Okay, this board looks like it might be ready to get installed, right? Looks like it's getting very close. Okay, so then testing this board before it goes onto the main board. Here's another picture of the test setup. Alright, and here's the emitter follower board. It looks like it's getting put together. Alright guys, they're building the inductor. Looks like they had some nice lathe equipment or whatever that is. That's a nice tightly wound inductor. Wow, look how nice tightly wound that inductor is. And there's the inductor off the machine getting measured. And there it is on the board. Alright guys, then they show how they use these wires, this cable, so that they can mount this transistor on the heatsink with the power transistors. And the bending of the leads to make sure everything fits. And there's our boards getting installed together. Alright guys, so what do you think? Pretty awesome, right? Now, who wants to build one? That's a big question. Hey, before we go any further, 2 big thumbs up to my patrons as always. Really appreciate you guys. And thanks Stuart for sending me these boards. Really appreciate that. And yeah, who wants to be in the front of this wave of the new Wolverine owners? The new amplifier. I think there's going to be a lot of stuff on the audio forums, and it's going to be a fun project. So you know, what I like to do is I like to get the test data. I like to do some testing of myself and basically test my setup is what I'd be doing, since this thing's tested out so well. I'm sure whoever builds this will do a great job. But that's what I want to know, is who wants to, that has the capability and that, you know, could do it within a fair, you know, without taking like a year to do it. Because I like to be able to post your results, show pictures of what you've done, maybe you send me photographs, something like that. So who would like to work with me on something like that, so I can help, you know, show the progress of someone building one of these. And I do have, like, as far as building the power supply, I do have some monster transformers, and I have a couple boxes of these caps. These are 37 millifarads, made by Mepco Electra. These are pretty high-end caps. They have the little dimples on them to keep them robust and stuff. There's reasons they did that for mechanical. And anyway, yeah, what do you guys think? Send me an email, okay? Whoever's interested. People, you know, John Audio Tech, if you're interested, that'd be awesome. But yeah, send me links. Maybe I'll send out both sets of boards. I think there's 2 sets of boards there. So if John Audio Tech's interested, send him a set, send somebody else a set. But let me know how long it's going to take you to do it and things like that, so I can get an idea. And what I'll do is I'll take, now, you know, guys, when I give away multimeters and that, I get like 5 or 6 people asking for a meter. So I don't get bombarded with people saying, hey, put me in the list, you know. So I don't get that many people. So, you know, people that have asked for, you know, when I give away a multimeter, which, guys, I've got some meters over here I got to review some, I'm going to give them away. So just a heads up. Anyway, yeah, I don't get a lot of people. So I'd be surprised if I get more than a few people asking for this, if that. So, but yeah, I just want somebody serious who really wants to do it, who can work with me, send me photographs or progress or whatever. If you can't test yourself, you can send the boards to me. I can test them and then send them back to you. Now, obviously, if you're not in the U.S., shipping can be kind of crazy, so I have to consider that, right? But yeah, wherever you are in the world, if you're interested in a set of these, you know, I can ship them to you, okay? But we might not be able to ship them back and forth, is I guess what I'm saying. And as far as supporting the power supply build, we can talk about that too. These were kind of expensive for me when I bought these, and I bought them a while ago when I was gonna do these kind of projects. I had a design of my own. Well, it's a design I adopted and modified, and I was going to build some amplifiers, and so I bought a bunch of stuff to do that, and you know, for other projects I want to do as well. So I don't even know what the voltage is on this one, but I've got a number of big transformers. So I've got one, I think I got 1 or 2 sets where I've got maybe, I don't know, 5 or 10 of each of that specific set, maybe even more. And then I've got some oddball ones. And the place I got these was in North Carolina. They're actually designing them for, I guess I can say now because it's been enough years, but Dynaco. So if you guys know who Dynaco is, so they're made for a high-end audio amplifier. So I got the extras. So anyways, there you go. Let me know what you guys think of this project. Give a thumbs up to the video. That's a free way to support the channel. Or you become a patron for as little as $1 a month. There's a super thank you button down below. Appreciate that too. And yeah, so let me know who wants this. And if I have more than one person asking, or more than 2, because I got to decide if I'm going to build a set, or depending on who emails me, I might give up both sets. So I don't know. I like to build a set here as having one pristine amplifier that I can compare everything else to, like this set of testing I'm doing. But yeah, so let me know, you guys. Give me your ideas, what I should do, how I should do it, and who wants to build a set. And I might have to put them in a hat, shuffle them around, and take a name out. Okay, so if there's more than one or two, because I have 2 sets. So if I decide not to keep the set, then, and if there's only 2 people and they really sound like serious people that want to build these things, I just don't want to set them out and sit on a bench, you know, like they might here. Like with me, they might sit here. So, because I got so many other projects going on, honestly, if I could do this full time, I'd be busy full time because I got so many projects. I'd be posting videos every day because there's just so much to do. Seems like every time I have one idea, you know, 6 more at least stem from that. At least 2 or 3 from even the simplest ideas. So, yeah. So, anyways, I'm just rambling on. I'm going to stop talking and sign off. Thanks for watching, guys. Wow, the Wolverine is here. That's pretty awesome.